Hello, everyone, and we're back. Thank you for joining us again. Hopefully, we're all refreshed. Just having a quick look at the chat section. I think a couple of great comments there about the presentations we've had so far. So glad you're enjoying that. Also, from Dan there, I think mentioned about this bait box changes that Alex mentioned. Again, we've put a link in the chat section just regarding that story. So have a little look in there. We'll try and be as helpful as possible with any of these bits we're mentioning and share some links with you. Fantastic. Okay, so that leads us on to the second part of the forum today. We have John Stewart from Edialux talking about a needle in a haystack for SPIs, something that is always a challenge as there are so many different varieties of them. But John, thank you. Welcome today.
Hi there. How are you?
We're well. What I'll do is I'll disappear for now and yeah, you have control. Thank you.
Thank you very much. Hi there, everybody. So my name's John Stewart. I work for Edialux, a pro pest distributor. And today I'm going to be, trying to impart some of my wisdom with regards to store product insect infestation, which, like Alex said previously, he was stating that from farm to fork, they can be attacked by various things, rodents and insects. So I'm going to share my screen with you just now. Can everybody see that okay?
That's working out. If you do start your presentation, there we go. Should start in a moment. Just from beginning on the left-hand side.
Yeah, I can see it, yeah.
Good
stuff. Trying to technology, eh?
There you go. There you go. Great.
Panic there. So yeah, I've been in the industry now for 17 years. I've been a field biologist for two of the major companies. And I remember I started off as a technician, and it can be quite daunting when you're thrown into some of these factories on, how do you go about finding an infestation, controlling it, and what should you really do once you stumble across it? And it's a bit like Pokemon. I used to make it my mission to catch them all. So I would go in there armed with a decent flashlight, some pheromones, and a spatula, and just go rooting through stored products. So stored product insects, they've been with us, for as long as we started to settle. We started growing crops and storing them in silos. You can see down here on the left-hand side that there's some silos that have pictures of them. These are from Egypt. This is where they used to store the grain when it came off the field, and they would dry it in these types of silos. And then you've got people processing it as well. So it was open to infestation from insects that will attack grain. We also started to store hides and fibers as well to produce clothing. And of course, they would be subject to attack as well from anything from common clothes moth to variegated carpet beetle. So they really try to get into our living space and destroy the stuff that we are trying to process and grow. So as time went on, populations grew bigger. So therefore, we needed larger structures to cope with the amount of food that we were storing. And we were processing a lot more food as well. We're processing a lot more food now as well. So at different stages within the processing, you can end up with insect infestation being introduced. And it causes quite a lot of impact on our ability to store food and process it. And as a direct result of that, you can have physical loss of commodity by direct consumption. So these are really primary feeding insects or secondary feeders that will bore into the grain or destroy it once it's been milled. And as a direct consequence of this, you can have loss of product quality. So it'll be downgraded. It can't be for human consumption. Also, if it's really spoiled, it won't be considered for animal feed either. Things like mycotoxins will grow in amongst stored material because of a rise in relative humidity and temperatures within silos. All the silos that store large quantities of product will have probes within them to measure temperature and relative humidity. And as that increases, you end up with mold growth, which can lead to contamination of the product. You also get contamination from insect fragments and frass as well, causing allergies. And mycotoxins are quite serious because a lot of them have been linked with carcinogenic, so cancer. They can cause food allergies as well. So it results in a lot of time wasted in growing, harvesting, processing, transporting, and storing products. It has a massive cost to the customer for both controlling and preventing future infestations as well. There's also health and safety risk as well because of the application of chemicals or maybe doing fumigation, which isn't really that good for the environment. So some countries also will put restrictions on trade due to potential damage to the economy. So, for instance, Australia has a zero tolerance approach to Trogoderma infestation, so Kappa Beetle. They'll quarantine materials and maybe fumigate it to allow it into the country. I think there's figures bandied around where they're actually investing something like 14 million to try and prevent this species being brought into the country, which is quite a significant amount of money. They're trying to protect their wildlife and fauna. They don't want this introduced. That's why you see some of these programs where they're looking in airports through people's bags, trying to prevent them bringing foodstuffs in that they haven't declared. So you get dropped into a place like this and you go, wow, where do I start? Modern life really is complex. So you might be overwhelmed at the start and you need to ask yourself a few questions. So what are they feeding on? What size is the infestation? How far is it spread? What impact is it going to have on my client? And how do I treat this and get rid of it? So there's different sort of feeding strategies for SPI. They'll have different food preferences. So some of them are commodity feeders or secondary feeders where they will attack it after it's been milled. Primary feeders will drill directly into grains and destroy them by laying eggs within them. The larvae will reside within the actual grain itself because it's been slightly maybe damaged to husk. It's allowed them to actually penetrate and start to lay eggs in them. You've got fungal feeders as well. So if, for instance, the grain isn't dried properly, you can end up with mold growth and you end up with these spores on the outside of them. So you'll get a lot of mold grazers, things like book lice. The predators that are going to be there as well that will feed on any of the stored product larvae or the adult insects. Scavengers, so these are ones that are generally in dank sort of conditions where you've got poor hygiene, and accidentals that will be brought in from the field as it's been harvested. So we'll look at the different strategies. So primary and secondary feeders. This is cowpea weevil, and you can see it's drilling holes into legumes, things like you've got maize there, black-eyed peas, and some kidney beans as well that are being destroyed. I've found these in houses before, so it's not just confined to food producers or storage units as well. So here we have quite a common insect that you'll come across. I've come across this in domestic situations where they're feeding on dog biscuits, but also in large plant bakeries as well, where you've got bread that's maybe gone hard and fallen into the line somewhere, hasn't been cleaned up. And I found them in coriander seeds. I remember going into a takeaway and lifting up a tub of coriander, looking at it, and the bottom of it was absolutely covered and crawling in these insects. And it was because they were putting the new seeds on top of the old seeds and not rotating their stock. So with SPI, it needs a lot of time for it to start to really manifest into something quite serious. And this particular insect, it can feed on strychnine and belladonna, which would normally kill mammals. One of the things to do is check your EFK units, because they're not just there to kill insects, but you can also use them as a monitor as well. And put down pheromones wherever possible to try and infiltrate these insects before it becomes a major problem. I made the stupid mistake once of collecting a whole load of them and putting them into a plastic takeaway tub, put it into the back of my car where my intentions were to take some of them from a collection of insects, and they punched holes through the hard plastic. So I ended up with an infestation of biscuit beetles in my car. We also have cigarette beetle. It's an important pest of museums. They look very similar to biscuit beetles, but they'll feed on tobacco, cereals, pulses, dried fruit, and spices as well. So again, these fly. So check your EFK units to see if there's any there. You can see the difference between them. A lot of people have difficulty identifying insects. With cigarette beetle, you tend to find it's got the serrated antennae, whereas the biscuit beetle has a more filamentous antennae with 3 sections to it right on the end above the elbow. So that's one way to tell. You also find that biscuit beetle have more punctuated marks down their elytra, whereas cigarette beetle are smooth. We also have grain weevils, Cytophilus. Like Alex was saying before, stuff's taken into storage and it lays there for quite a period of time while it's going through the process of drying. So this can be a particular problem in a sort of that kind of scenario where they can get into silos, start to raise the temperature, the relative humidity, and destroy the grain. They prefer wheat and rye, but will infest other cereals as well. I actually got called to a domestic situation where this chap's pantry was absolutely covered in them. And to be honest, he was doing a good job of storing everything. Everything was in plastic containers. Nothing could get access into it. But what I found was one of those neck warmers that you get that you put into the microwave. They actually have grain in it. So you put it in, heat it up in the microwave, wrap it around your neck. He hadn't done this. So the actual product that he got was infested before he brought it into his house, and it was hanging up behind the pantry door. And after a while, these things started to emerge. He was flabbergasted when I took the neck warmer out of the pantry, laid it onto the kitchen table, grabbed a knife, and then proceeded to slash it open and tipped it out onto a tray. And the insects were everywhere. So that's something worth keeping in mind. It may not necessarily be food, but it could be dried flowers or something like that as well that's got seeds in it that could promote infestation of this. And they don't fly, so you'd be looking to put down sort of blunder traps where they'll wander into them. So to differentiate the difference between rice weevils and grain weevil, have a look at the elytra at the back and look for thumbprints. They have these kind of orange markings on the elytra, which can be sometimes not that distinctive, but if you get them under a good hand lens or a field microscope, you'll be able to see the difference between them. They're more commonly found on wheat than rice, but they'll also infest pulses as well. They can cause excessive mold growth as well on products, and the adults will fly. So you can usually find them hidden, the larvae are hidden within the actual grain itself. This is merchant grain beetle, Rhizophilus mercator, and they are pests of oilseed, chocolate, cereals, but they'll infest a variety of different premises. We have sawtooth grain beetle as well, common pest of cereals and cereal products. They're mainly found in grain stores. So again, this is another insect that will cause quite significant damage if allowed to get to large levels. And again, use insect monitors, multi-catch species traps to try and lure these things in. And to identify the difference between the two of them, again, you need a good hand lens and really know what you're looking for. The distinctive ways of actually separating these two species is it's the gap behind the eye, and with Mercator, its head is more triangular. This is the most common one that you'll probably come across if you're doing bakeries or anywhere that holds large commodities of flour, large quantities, sorry. You'll also find them in mills as well. And I think the reason they get called confused is because they crawl around in sort of any flour that's been left or spilled, and you see these rather strange tracks throughout the flour. Very common pest in the UK. We also have red rust flower beetle, Tribolium castaneum, probably the most common imported beetle. Feeds on cereals, nuts, spices, dried fruits. Adults can live for over a year. Heavy infestations make the flower smell off and kind of musty. And the larvae, they can eat each other. They're quite predatory. They'll eat other insects as well within the product. Here we have Kappa beetle, so Trogoderma granarium. It's quite difficult to differentiate the species of these because there is quite a number of them. So it's better getting them professionally identified. But one of the things you will find if you come across this is the larvae, they will try to get underneath your insect monitors. So actually lift up the insect monitor and have a look to see for larval caskins or any live larvae that are there. They can survive starvation for long periods of time, and depending on the quality of the food will determine how quickly it will go from larvae to adult. So it can be rumbling on for some period of time. I've found these in dried milk, booster powders that are used to go into manufacture coffee, and in cereal as well. Dealt with a heavy infestation in our cereal factory, and it could have cost us as a company £1 million because it had been misidentified. Species that we had were able to fly. So hang delta traps up and get them spaced around the factory to see how far the infestation has actually spread. And this particular insect, it can gain access into small holes in packaging. So you've got to be quite diligent when you're looking for these. So another one that's common that you'll come across within mills and bakeries and things like that. It's your Melmoth, sort of festia. They have very drab, zigzaggy markings on their wings. If you're collecting specimens to be sent off, you'll probably find by the time it reaches the likes of us or someone else that's identifying it, all the scales will be missing from it. As they're flapping around, they'll come off, or if you try and pick them up. They're quite prolific web spinners, so they'll produce a lot of silk. And that causes major problems inside machines because you end up with frass, which is the webbing, and also feces from the larvae building up within the machine, and it can cause production lines to actually grind to a halt because of the damage it can cause. And you can use Zeta pheromone, so you could have moth pots hung up or demi-diamond type traps used around the factory or the storage process to actually intercept these. So the female pheromone will trap males. And one of the things not to do is keep the packets of pheromones in your pocket, because it can actually leach it into your bloodstream. Not that it causes any harm, but if you walk into somewhere like I did, I walked into a supermarket and think they thought the cheese had slipped off my cracker as I was like waving my hands frantically in the air to get these moths away from myself because they were trying to mate with me. Obviously had female pheromone going through my bloodstream. This is another one that's another type of moth that you'll come across quite frequently, Indian mealmoth, so Plodia. They're grey-brown banded, and they have lighter scales towards the top end of their body or their wings. They're a primary pest, so they can cause quite a lot of damage to products, so nuts, cereals, dried fruits, oils, seeds, oatcakes. The adults don't feed, and their primary function is to go and mate. And you can see from the picture in the middle here of a female resting with her abdomen raised in the air, releasing a pheromone plume to try and attract males in. And when you come across these, you'll find them at the wall ceiling sort of interface within factories, where they'll crawl up to a high level to pupate and go into diapause. Diapause is when they go into like a resting stage. If conditions are unfavorable, they'll go into like a rest until temperatures start to rise, and then they'll emerge from pupation. And the picture on the right here, this is a word of warning for anybody that likes to eat pistachio nuts while having a beer. I've encountered this. So you're sat there maybe on a Friday night, relaxing, having a beer, cracking open these pistachio nuts, firing them into your mouth, and who doesn't like a snack when they're having a beer? I would check first, because sometimes you can find them like this, where it's got the larval droppings and frass in amongst it. We also have fungal feeders as well. So this is something else to have a look for on your crawling insect traps. They will feed on mold spores within the commodity, usually grain, that's been poorly stored. So when it's been brought in from the field, it hasn't been dried thoroughly, and then you end up with these fungal feeders turning up. This is another interesting critter that I've come across a couple of times. So this is dried fruit beetle, and they are oval and flattened. And one of the characteristics of them is they have clubbed antennae. They do fly, some of them, and you'll find them in fly killers. The elytra are generally, this is the wing casings, are generally shorter than the abdomen. You see two parts of the abdominal segments are easily distinguished when you find this species. They're like dry ripening fruit, newly harvested, and damp grain as well. But I've found these in a bar and also in drains as well. They're fungal feeders, so you're going to look for somewhere which is particularly smelly. So if you've got a leaking drain where potentially water and food residues going into a wall cavity or something like that, you will sometimes come across this insect. This is another one to look out for. It has huge biotic potential. So one female can give rise to 120 to 456 offspring. So pretty quickly, you can end up with a massive infestation of this insect. They show incomplete metamorphosis, so they'll go through various nymphal stages before they reach adult size and become able to breed. Generally, these are secondary infestations, and you end up with they're feeding on mold because the temperature, relative humidities went up. They move around in really jerky type movements, and they love high humidity. So between 70 and 80% relative humidity. I've found them in newly built houses because they leave the roof timbers outside to the environment where they're going to get wet. Then they'll erect the roof, put slates on and sarking, and then these things start to emerge from the timbers from cracks within them. And because the water can't escape from the house, you've got this continuous cycle of it, the water being made into a gas, then it condensating, and then turning back to water again. You can find these in houses. Also, wooden pallets are bad for them as well, because again, they're stored outside. You'll get microfungus in the cracks of the pallets. Then they're brought into the warehouse, and people are storing product on top of it, and then you'll end up with infestation of book lice. Can use sporicidal sprays to try and reduce the amount of spores present on pallets potentially, or heat treat them to eliminate them. So once you've found these insects, you'll be panicking. You're like, right, what do I do? So think IPM, keep calm, and just go through the motions. This is the process that I would take when I come across infestation of SPI. So I would collect specimens, document the location, what type of commodity they've been feeding on. If you don't know what species is, send a specimen for identification. We do free identification as well, so they can be sent to us or any other supplier that offers that service. If you've got a field biologist within your branch or within your company, send the specimens to him and get them identified. That's the most important thing, because if it goes to court, you may be asked as to what the actual insect species was. Arrange for an in-depth inspection. So you're going to roll your sleeves up, get your spatula out, take a torch, specimen tubes, and you're going to start raking through machinery. However, this should be done when the machines aren't running. I can't emphasize that enough. And ask if you can open up panels, because some of them have automatic cut-offs. So when you open a panel, the machines may grind to a halt, which could upset your customer. Also, you don't want to get dragged into a piece of moving machinery. So get everything turned off during downtime, get in there and start rooting about and collecting insects. Up at the top left-hand side, this is the kind of thing that you'd be looking for. So webbing and frass, so insect droppings. And if you start teasing that apart, you'll find larvae in it and pupal caskins as well, live insects. Just get down and dirty and crawl about the floor, get into the machines and get them to open up panels for you. When you've discovered them in a certain area, you need to get them to start acting pretty promptly. That's cleaning the actual machines, opening the machines up and getting rid of any sort of excess material and infestation when it's present. So vacuuming it up is a good way of doing it. Step 4, place monitors all over the place to try and identify it. And the key thing is to understand what species it is first, because some pheromones are very species specific. So you'd be wasting your money putting something in which isn't specific for that insect that you're trying to trap. There's various types on the market. So one up at the top left is your multi-species catch trap. It's a bit like a pitfall. It's got pheromone and food attractant in it. The insects crawl up and get stuck there, ready for you to identify. We've got pheromone pots, which are moth pots at the bottom, where you can put your coloured pheromone lure in the top, and that will attract moths in. Pitfall traps, that's put directly into the commodity, and any insects that are crawling around will fall in through those small holes, get trapped in the bottom, and you can then have them identified or identify them yourself. And we've got delta traps. The glue is actually impregnated with pheromone and they are suspended. Any flying insects will get caught in actually in the trap. One of the things that I would say when you're placing any sort of pheromone traps around your site is to have them placed in areas where you've not got a draft, because obviously that will blow away the pheromone plume. You want it to be hung somewhere where it's not going to be disturbed or hit with forklifts. I've come across pheromone traps that have been smashed to bits because people taking stuff off racking, they'll destroy them. Draw up a cleaning and treatment schedule. So work with your client, ascertain when they're going to be having downtime or any repairs. You can get in at that point and start to sort of have a right good route around the machines. And treatment really should be scheduled when there's very little people within the area. So it'll be maintenance people and maybe a cleaning squad, but the production might not be there. So it allows you to get in and actually do some spot treatments. Perform trend analysis. So I use this piece of software here to map Trogoderma infestation in a cereal production site. And what it did is it highlighted the inefficiencies in their cleaning. So don't just look in the machines, have a look at the actual building fabric as well, because when you're dealing with dry powdered product, it gets absolutely everywhere. It ends up airborne and laying on top of RSJs, your road steel joists, on sort of bulkheads of walls and things like that. And if they're not cleaning that, the infestation can be coming from the building fabric into the machine, or from the machines onto the building fabric, and vice versa. Check incoming goods to ensure that they're not reintroducing infestation back into the site. So they should be doing good quality control checks on the stuff that they're buying in to produce whatever they're making. Use the data that you're collecting with your monitoring. So if you're doing trend analysis, have a look to see whether it's distinct areas that are maybe being infested, and use that information to make decisions on further housekeeping, further cleaning, and treatments as well. And we come to treatment. So where do you start? I think the most important thing of any sort of IPM program when you're dealing with SPI, is to actually do good housekeeping, good cleaning, and have good scheduled maintenance. So when they're opening things up, staff should be vacuuming out loose product from dead spaces. So if you've got material collecting within the machine that isn't actually moving through for production and it's just collecting there over a period of time, it will become infested or tainted. So vacuum cleaners are brilliant. If it's got a HEPA filter on it, it will take any of the sort of dust and insects, eggs, larvae, frass out from within the machine. Some factories also have fixed vacuum attachments on the walls, where you can take the hose and just plug it in at different points around the factory where you can get in and clean. Also check the warehouse as well, because you tend to find that on these sort of Dexine racking systems, they don't clean as well round about there. So you end up with material trapped that's maybe been damaged and falling in between the actual footing of the racking. So that's worthwhile looking around there as well. The in situ heat treatment. So if the machine is heavily infested, after it's been cleaned as much as possible, then it can be shrouded in plastic or a tarpaulin and heat up so that it will kill any of the insects, all life stages within the machine. Cryonite can also be employed. So it comes out at minus 78 degrees Celsius, and it uses liquid carbon dioxide, kills on contact. It's non-residual and it's non-toxic. So you can treat food preparation surfaces with that. It makes actually a good cleaning aid as well. So if the stuff that's trapped within trunking and things like that, it can be blown out using the jet nozzle. It's safe to use on electric cables, but don't use it on circuit boards because it will damage them. With regards to things like book lice or mites, reducing the relative humidity right down, so drop it below 60, and you'll kill the insects because they're soft-bodied, so they'll dehydrate and die pretty quickly. And then, last but not least, chemical control, and that should be last on the list. I think should be trying to clean and remove it physically before you start reaching for your sprayer. Obviously, it has to be used. We use a multifaceted approach where you try to use everything in your toolbox to remove the infestation. And of course, it can only be done once production stops. Can't treat food surfaces, so you need to use everything at your disposal. Mating disruption as well. That's another good option for control when you've got infestation of moths. They work 24/7. They don't cause any problem with production. It's low labour as well, so you're not spending a great deal of time there trying to kill adult insects by going in and fogging or something out of hours. And it won't interfere with production either. So there's various types of mating disruption out there. Those are good for keeping the numbers at a manageable level. So in summary, think small, open everything up, draw up cleaning schedules, get the insect identified if you're unsure, monitor the spread of the infestation, and use the data collected to make decisions on cleaning and treatment, and check incoming goods for evidence of infestation. It's over to you, Natalie. Thank you very much.
Fantastic. Thank you, John. That's so much, isn't there, to think about when it comes to SPI. There's a question in there regarding book lice, but just to elaborate on the question, which was regarding chemical treatments and what products you use. But book lice is a common question or a common issue that we get pest controllers ringing with, saying, I've got them here, obviously possibly damp, and talking about humidity. And sometimes it can be really hard to implement that. But have you got any sort of interesting real life scenarios you've had that's been challenging, but actually you've overcome it?
Yeah, I got called out to a domestic, and at that point I was a consultant, so I get sent out to give some technical support in the field. And I was finding that the technician was using water-based insecticides to try and quash the infestation, but he was actually making it worse, because once the insecticide, if it's not that residual, or the residual effectiveness wears off, then you'll find that all you're left with is more dampness, because quite a lot of them are mixed with water. So that can cause a problem. So Again, I would use a dehumidifier and air blower to try and remove any humidity there. It's the safest option as well.
Yeah, absolutely. Is there, with the dehumidifiers, is there any, it's going to be site specific, of course, but what's the sort of longevity? How long will it take for that to kind of get to the level that's suitable to be able to, disrupt the sophids book lice?
It really depends on the level of moisture that you've got there, and whether there's any sort of underlying building sort of fabrication issues. So if you've got ongoing leaks, or the place was very, very wet, it can take a period of time. But air blowers and heaters will speed that up, because you want to change it from sort of liquid to gaseous state so that the dehumidifier can remove the water. You have to go back and keep emptying it, otherwise you'll end up flooding potentially a roof space or something like that.
Right, so it's possibly a potential that pest controllers may want to work with maybe a building or construction expert that could, offer these services if we say don't have the things available to us.
Yeah, definitely. I mean, I've hired dehumidifiers before, air blowers and heaters to try and overcome that type of infestation before in the past. Yeah. Again, fantastic. Wooden pallets, I would switch to using maybe aluminium or plastic pallets.
Mm-hmm.
One, because they won't trap any moisture, and two, because of foreign body contamination, bits, splinters of wood and things like that. So certainly in production areas, you wouldn't be taking wooden pallets in.
Great. Yeah, good suggestion. Matt Green here asks, hi, John, placing pheromone traps near external doors isn't a good idea, but are they better in still air or with some airflow to move the pheromone plume?
They're better in still air, because it will be released and you'll end up with this nice plume of pheromone coming from it. If it's put against a wall or next to a door, any sort of airflow will push the pheromone plume further away and start to disperse it. So it doesn't work as well. Yeah,
of course. So still air. Good advice. And then one more question asked for elaboration. So you mentioned a court case. Can you give a short scenario where this has happened and what a technician or company might have to prove?
Well, if, for instance, stuff was sent out to the public, so it met, somebody purchased something from a supermarket and it was infested, then potentially if you're the technician servicing that particular food industry that's produced it for the supermarket, you may be called upon where you're trying to fight or help your customer fight a case in court. So identification is critical. Said before, there was infestation of Trogoderma within a factory. It was misidentified by a company that we'd sent it off to for identification. I knew it was wrong because the species that he described it as doesn't fly, and we were catching them in delta traps. So that could have cost our company potentially £1 million should the actual fumigation have went ahead, because we were going to fumigate it with sulfurofluoride. So we could have lost out, and our customer could have been prosecuted if it was for export, say.
So in the worst case scenario, maybe vicarious responsibility or liability could be certainly an issue there. And also you lose customers, don't you, by providing
it's loss of goodwill, isn't it, really? Yeah.
Absolutely, yeah.
Yeah.
Great, good stuff. Well, that's all the questions that have come in. That was action packed, and really appreciate that that refresher on it. And if again you've got your contact details, maybe pop in the chat section, and if anyone wants to get in touch with you, I'm sure they can.
Excellent.
Great.
Thanks very much.
Thank you, John.
Bye-bye.
Take care.